So in this video, we will start our discussion on 6-LoWPAN. So let's try to understand what is 6-LoWPAN. So 6-LoWPAN is an acronym of IPv6 over low power wireless personal area networks. It is a simple low throughput wireless network which comprises typically low cost and low power devices. The common topologies which are utilized in the 6-LoWPAN are star, mesh and combination of star and mesh topologies. Here again the physical and MAC layers conform to IEEE 802.15.4 standard. The packet size is relatively small, that is of 127 byte, because the IEEE 802.15.4 layer cannot handle large packet sizes. Here 16-bit short or IEEE 64-bit extended MAC addresses are utilized for the device identification. The bandwidth is low, typically in the range of 250 kbps if we are using 2.4 GHz channel. It is low power or typically battery operated network. The 6-LoWPAN is relatively low cost network. So what are the advantages of 6-LoWPAN network? Here low power wireless embedded devices connected using familiar network technology. So this we will discuss in detail because 6-LoWPAN helps in connecting the devices which are running on IEEE 802.15.4 and they want to communicate over standard TCP/IP. So it helps in connecting the devices with familiar network technology such as TCP/IP. It can be interoperated in real applications because lot of applications and other devices are using the TCP/IP layers. It can interoperate with various traditional computing infrastructure because once the data is communicated over TCP/IP layer, it can be consumed by any device having the TCP/IP layer. It can also utilize modern security techniques which are built in the standard TCP/IP layers. Now, what are the current challenges which have led to the development of 6-LoWPAN? So the first challenge is the high number of proprietary and semi-closed solution such as ZigBee. So ZigBee falls under semi-closed solution where the MAC and physical layer is IEEE 802.15.4 layer, while the network layer is a proprietary solution given by ZigBee Alliance. Similarly, Z-Wave is entirely different architecture where the physical media access control and the network layers are entirely different. Similarly, Smart Mesh and other type of solutions will have different kind of architecture. Now, most chip vendors claim to be compatible with their own standard, as we saw in case of Z-Wave, where the Sigma chips are having only the Z-Wave architecture built, and because of that they are not compatible with other type of solutions. They can be compatible with only Z-Wave architecture. Many non-interoperable solutions are available in the market which are not solving all the problems. They are solving only some specific problems. Why? Because they have different architectures and different protocols, and because of that the devices are not easily interoperable. The architecture and the protocol must be based on open standard. This is what the need of an hour. But because of having non-open standard, we are facing the problem related to interoperability. We need flexibility in many dimensions, such as it should support wide range of media, it should support wide range of devices, which are not available in the other protocols and architectures in the market. Here, the requirement is that the architecture and protocols need to be highly secure. It should be plug and play kind of solution, and it should be easily scalable. Since the existing solutions such as Zigbee and Z-Wave are not capable to ensure these three important things, the requirement was to develop the new protocol for the IoT devices. What are the other challenges other than what we discussed previously? There is no solution exist other than 6LoWPAN which can make the IP layer run over IEEE 802.15.4 network. Stacking IP and above layers as is may not fit within one 802.15.4 frame because the 802.15.4 frame has its own limitation. What is the limitation? Limitation is the size of one data packet. So here IPv6 header itself is of 40 bytes, TCP header is of 20 bytes, and UDP is 8 bytes plus other layers will also have the other header sizes. Then we will have very less space available for the data. So that's why the standard IPv6 data cannot travel easily on 802.15.4. Also, not all ad hoc routing protocols may be immediately suitable for 6LoWPAN. The requirement which we have for the routing is DSR, that is dynamic source routing, which may not fit within a packet if we use IEEE 802.15.4 at the MAC and physical layer. Also, the AODB, that is ad hoc on-demand distance vector, will also not be suitable to be incorporated along with 802.15.4 because it will need more memory. So what is AODB? AODB is an ad hoc on-demand distance vector which is a loop-free routing protocol for ad hoc networks. It is designed to be self-starting in an environment of mobile nodes, that is the nodes which are movable, and withstanding a variety of network behaviors such as node mobility, link failure, and the packet loss. So because of that, the standard solution which are available at the TCP IP layer cannot be utilized in the IoT devices until we implement IPv6 based wireless personal area network. Here the limited configuration and managements are necessary because we are having IEEE 802.15.4 as physical and data link layer, and we also need security with multi-hop capabilities so that the energy constraint which we have in case of the IoT devices can be addressed to certain extent by hopping the data to nearest neighbor. Now, what are the advantages of IPv6? So IPv6 is more suitable for the mandated higher density statelessness. Here no network address translation is necessary. So what is network address translation? It is a method of remapping an IP address space into another by modifying the network address information in the IP header of the packet while they are in transit across a traffic routing device. This technique was originally used to avoid the need to assign a new address to every host when a network was moved or when the upstream internet service provider was replaced, but could not route the network address space. So, because of the earlier limitations of having limited number of IPv4 addresses, we were extensively utilizing network address translation technique for readdressing or reassigning the network addresses. When we have IPv6 enabled, the number of IP addresses will be very large in size and we will not need network address translation. We can also have the possibility of adding innovative techniques such as location-aware addressing when we use IPv6. What are the limitations of IPv6? It is having the larger address width, that is typically 128-bit addressing is required for IPv6, and another limitation is we have to comply to IPv6 node requirements, and since right now we have lot of devices which are compliant to IPv4, so we need to modify the configuration of those devices so that they can be made IPv6 compliant. Now, what is the current status? If we are not utilizing 6LoWPAN, we have to utilize the protocol translation gateways, which is very complex to manage and it lacks end-to-end routing consistency, multi-topology routing and management security challenges. So what is protocol translation? So typically we might have various subnetworks where we are having various IoT protocols running, say Zigbee or Z-Wave or some other protocols running. Since they cannot travel over the network, we need to first convert those data packets into a standard TCP/IP protocol so that the data can travel over the network. So we need to deploy a lot of protocol translation gateways so that it can accept the data from various subnetworks having different protocols, and then the converted data can travel over the network. So this is the problem which we have when we have the protocol translation gateways, because we have to implement multiple translators to share the data over the network. Now again the problem will happen when you send data from one set of network to other set of network at the receiving, and also you have to again convert this to the proprietary protocol or the semi open protocol such as Zigbee. Then again you need protocol translation gateway so that it can be back converted into the required data format.